Hi folks, welcome to this sixth video in a crash course in counting. In the first video we dealt with fundamental counting principle, then we dealt with factorial notation, then permutations and combinations, and then telling the difference between permutations and combinations. In this video we're going to deal with trying to decipher the words and or in counting questions. And as always, there are notes in the video description as well as filled in notes, so both blank and filled in. And there are some practice questions within there as well. So as a very, very broad generalization in counting questions and also in probability, the word and often means multiply a result. If you have a compound event or some event that has two parts, one part and another, you often multiply your possibilities. If you have the word or, it typically means to add your possibilities. So if we look at this first question, how many ways are there to line up 5 or 6 people from a group of 20? Let's think about this. If we just did 5 people, okay, we're lining them up. So clearly that's a permutation question. We have 20 to choose from, and we could figure out what 20p5 is. Let's head to the calculator and do that. For me, I hit math, PRB. I put in my 20 afterwards. For you, it may be different. I get 1,860,480. If just as sort of a separate question, I figured out how many ways you could do this with 6 people. Well, it wouldn't be a lot harder. It would just be 20 people to choose from, and I could choose 6 of them. So math, PRB, again, NPR, 20, pick 6. And there'll be a lot more possibilities. 27,907,200. And if I want the number of ways that I could get either one of these scenarios or the other scenario, I just take the number of possibilities there are for the first and add it to the second. And that will give me my total number of possible ways this could happen. And we get 29,767,680. A lot of ways. Let's move on to another example. A team's to have 4 children and 3 adults. So it's a team. The order probably doesn't matter here. How many different teams can be formed if there are 4 children and 7 adults to choose from? You know what? Let's change this a little bit so that it's 8 children and 7 adults to choose from. So we're going to pick 4 children, and 3 adults. That's what we want. And if I did each of these pieces separately, you've got 8 children to pick from, and you're going to choose 4 of them. Order doesn't matter, so I'm using combinations. For the adults, you have 7 to choose from, and you're going to take 3 of them. Okay? And it's really very much like fundamental counting principle. There's a certain number of ways you can choose from the children times the number of ways you can choose from the adults, because you're going to choose both of these things. That's what the and means. So I'll multiply these together. Now you can find these individual results and multiply them together, or you can just do it all at once. I'll show you what I mean. If I do HC4, that's 70. If I do 7C3, I get 35. I could multiply those two things together. I'd get 2450. Or I could do it all at once. So math, PRB, NCR, 8, choose 4, times, and I'll do the same thing here again, 7, C3, and it will work it all through for me at once. I'll get the same answer. So I can show the answer here is there's 2450 different possible teams that can be made. One last one involves card hands. So how many 5 card hands contain at least 3 diamonds? Often at least questions, or at most, require considering different cases. So there could be 3 diamonds here and 2 non-diamonds. That could be your hand, right? And it would satisfy these conditions. Or case 2, you could have 4 diamonds and 1 non-diamond. Okay, that would also satisfy these conditions. Or lastly, you could have all 5 diamonds. And that would satisfy these conditions. Now, you may or may not know the card deck very well. There are 52 cards. Half of them are red, so that's 26 are red. Half of those red ones are diamonds. So there are 13 diamonds. Order doesn't matter, how you hold them in your hand. So this would be 13, choose 3, times, because it's and, 2 non-diamonds. So there are 39 non-diamonds in the deck, and you would choose 2 of them. And we can head to the calculator and work that through. When we run it through, we'll get 211,926. Okay. And now we'll do case 2 separately. You could have 4 diamonds, so you got 13 to choose from. 13, choose 4, and 1 non-diamond. So that would be 39 non-diamonds to choose from. Choose 1. Now, just as an aside here, this 39 choose 1 is probably overkill. If you have 39 things and you're going to choose one of them, how many ways are there to do that? Well, there's 39, so we probably could have evaluated 39C1 just as 39. But we get this number, 27,885. As a last situation, we could have all 5 diamonds, so that would be 13, choose 5. And that's going to be 1287. Now, here's the thing. You might have case 1, 3 diamonds, or you might have case 2, or you might have case 3. Okay, so you might have 3 diamonds, 4 diamonds, or 5 diamonds. And so each of those has a corresponding number of ways it can happen. But it's not like you can have both case 1 and case 2 at the same time. You can't have both 3 diamonds and 2 non-diamonds and 4 diamonds and 1 non-diamond at the same time. So it's one or the other or the other. That means since these are ors, we add them up. So 211,926 plus 27,885 plus 1287 gives us 241,098 possible ways. As usual, there's some practice questions that you can do around this. So there are 3 questions here, and there are answers here at the very bottom where it says and or questions. Those are the corresponding answers. I hope this has been helpful. Good luck with the material, folks, and take care.